Welcome everybody to Glow Your Own 6. It's the last session where we're going to be adding a servo motor to create movement in our LED Arduino lantern creations. We could just get straight on with doing some coding. Should we do that?
Absolutely, it sounds like a great plan to me. Thank you, Dane. Hello everybody. I'm really pleased that you could join us for this final session of Glow Your Own. So this session is pretty cool because we are going to use servo motors. So we're going to use motors to make things move. So if you remember last week, Dan was making some like sea creatures or stuff. I think it would be cool to get the sea creatures' legs to move, although perhaps slightly scary. Well, you know, if you catch it out of the corner of your eye, it could be a bit scary. So that's what we are going to do today. We are going to use a type of motor called a servo motor. And we, at the lab where I work, and I'm sure at Culham as well, where Caitlin and James and Jan work, we use motors for all kinds of different things in our experiments, but you could also use them to do the stuff that we're going to be doing today. So if you all head over to Tinkercad, I'm going to share my screen and we can build our new circuit. So just like we've been doing for the last few weeks, we're going to build our circuit virtually on the computer. We'll test it and code it on the computer, and then we will build it in real life as well. So if you all join Tinkercad and then create a new circuit, so clicking on new and then circuit, then we'll get here. I'm just going to change my circuit name to Glow Your Own session 6, so I remember what it is. All right, so let's get started. We're going to start the same way that we started all of our circuits previously. So we're going to need our Arduino. So I'm going to grab that from the right hand side of the screen, put it over there. And I've just remembered that I said I was going to put sticky notes to tell me which is left and which is right, and I totally forgot. Never mind. So we're going to bring an Arduino over, and we're going to get a breadboard out as well to help us make our circuit. So there we go. We've got our breadboard and we have our circuit. And the next thing we're going to bring out is a servo motor, or a micro servo motor. So you can see that that one is just down here. So there are different types of motors that you can use, and we use them for different things in different situations, but we're going to use a very common kind of motor called a servo motor. So if you pull that out here, it looks like this. It's in this nice blue thing, and just pop it by the side of the Arduino. Okay. We'll show you what the servo motors look like in real life when we're building the circuit, but they do look fairly similar to that. But your one might not have these little like blades at the top. They might be separate, and you might just have to pop them on later. That's often the case in these Arduino kits. All right, so a servo motor needs 3 different things. And helpfully on Tinkercad, it tells you what each of those things are when you hover over the connection here. So if you hover over the one on the far left, it says ground. So we need to connect that to our ground on the Arduino. It also needs some power. So we'll connect that up to the power to the 5 volts on our Arduino. And then it's a signal. So this is where where the coding is going to come in, and we're going to code our Arduino so that it sends a message, an instruction to the servo motor that basically says turn now or stop turning, or whatever we want to send it to. Okay, now we could, if we wanted to, just connect this directly up to the Arduino and ignore the breadboard entirely. Because we're just doing a servo motor at the moment. But because you might want to add things on, add LEDs on, or use one of the circuits that you were doing previously, I'm going to connect it through the breadboard. Okay, so firstly, I'm going to connect my Arduino to the breadboard. So the ground, the one that says GND, to the blue line, the minus line on the breadboard. I'll just zoom in a little bit so you can see a bit more clearly. Like that. And I'm going to make my wire orange because it's going to ground. And I'm going to move it a tiny bit so it's nice and straight. You don't have to do that. So that's connected to the ground. And then I want to connect power to my power line. So I'm going to connect this power line with a wire around the Arduino to the pin that says 5 volts or 5V. And I'm going to make that a red wire because it's going to the power. Okay, so now I've just got a nice connection between the breadboard and the Arduino that makes that goes to the ground, to the negative, and to the power or the positive. All right. Now, the first wire is going to be connected to the ground. Sorry, the first part, the first pole pin thing on the motor, we're going to connect it to the ground. So I'm going to connect it to the ground through the minus line here. So I'm just going to draw a wire from here all the way to the ground. Don't know why I decided it was going to be longer. It's not, it's going to be like that. Okay, I'm going to turn it orange. So I know it's a ground wire. And then that's that. All right, I'll pause just for a second because I can see there are a few things in the chat. But I think it is just nicknames, which is brilliant, but I'll pause for a second to give you all a chance to catch up. If you're ready for the next step, then you just pop an emoji in the chat or raise your hand or do a thumbs up or something like that, so that I know that we're ready to move on to the next bit. Brilliant. Dane has an LED, a light bulb. I like it. All right, so we'll just wait for a second. Fantastic. Lots of you. Oh, someone's put a pizza in there again. Now I want pizza. Every time. I always end up so hungry on Wednesday evenings because of this. And I don't even have any pizza. All right, I'll give you all just another minute to do that. So we need our servo motor and 3 wires with our Arduino and our breadboard. We've just got 2 more wires to go before we finish our circuit. All right. Looking good. Oh, chips and pizza. That sounds like a great plan to me. All right, fantastic. Now remember, this is being recorded, so if you're not quite there, you can always pause this and watch it back later on. Okay, the next one we're going to do is the middle one on this Tinkercad, which is the power. So I'm going to draw a wire that goes from this middle hole in the servo motor to my power line on my breadboard, like that. And then because it's a power, I'm going to turn the wire red. And this just really helps me figure out which wire is going to which place really quickly and easily. So now that's connected. It goes in a circuit, so it's got its power and it's got its complete circuit because it goes from the ground along here, along this green highlighted one, all the way to this wire, through the motor, and then up through this wire to the power, all along the breadboard, and then down through the wire back to the Arduino. So we've got our complete circuit, which is a good step. We definitely always need that. But we need to be able to send instructions or code to our servo motor. And that is the final pin on the servo motor, which is called the signal. And that's the signal it receives, the instructions it receives from the Arduino. So we're going to connect that out to one of the pins on the Arduino. I'm going to go all the way around so that none of my wires are crossing. So it's nice and neat on this, and I'm going to connect mine to pin 2. And because it's an instruction that's going out, I'm going to change my wire to a yellow wire. No, I'm not. I'm going to change it to a green wire because that's my system. No, that didn't work, did it? To a green wire. There. So now I can send instructions. I can send code to the servo motor so that we know what we want it to do through this green wire, through pin 2 on my Arduino. All right, and that is the whole of the circuit for the servo motor. You can obviously also add LEDs, or you can use the same circuits that we've been using for the past few weeks. But that gives us enough just for this servo motor, this new bit that we are doing today. Right, now we have to send it instructions. Pop something in the chat if you're ready to start the code. Fantastic. Oh, thumbs up and a light bulb. I like it. That's good. Oh, and then a cake. All right. Just give you one more minute. Remember, again, this is recorded and we will be sending you the written instructions as well. So if we are going a bit fast, you can always pause us and come back. All right, I'm just going to move it over to this side so you can still see that connection of the motor. I'm going to start the coding, which is always my favorite bit, because that's the bit that makes the most sense to me. All right, so the standard bit of code that is there, we don't need. So I'm just going to delete that by putting it in the rubbish bin down at the bottom. And we're going to use a new type of code that we haven't done, a new instruction today. And that is we're going to ask the computer to remember some numbers. And we do that using variables. That's what we call them. And so you can see those here on this kind of pinky blocks. They are variables. And it's just a fancy word to say, computer, I want you to remember this number. All right. So to create a variable, you just click on the button that says create variable, and then you can name it anything you like. But it makes sense, just like we've been naming our codes in our circuit, it makes sense to name it something that you're going to remember what it means, because otherwise you'll come back to the code in 6 months' time, and I'm sure the others have done this and go, now what did I mean by variable A or something? So it always makes sense to call it something that you're going to understand. And what we're going to get the computer to remember is the angle that we want our little servo motor blades to be at. Okay, because that's how a servo motor works. You tell it what angle you want these blades to be at. So I'm going to call my variable angle, like that. So you just type in the name and then click OK. And then it's created some code blocks for you. And the first thing we want to do is set a value for that angle. So we wanted to start up here, and so I'm going to set this. I'm going to set the angle. So I'm going to say computer angle equals 0. Remember that, please. All right. But what we want actually to do is for our servo motor to move. So we want to change the angle. We want it to go from here to 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 here, all the way down. And so we're going to create another variable that we're going to call change, because it's the amount that we want that variable, that angle, to change by. So I'm going to create a new variable and I'm going to call it change. If you do have any questions, do pop them in the chat. I know Sarah and the others are watching it to make sure that they can help you as quickly as possible. So we're going to set our new variable change, and you can see here now there's I can change it to here. You can change which variable you're talking about by clicking on this little arrow to change. And then I'm going to set it to 15 degrees because that's a reasonable number. But you can set it to a different number. There are 360 degrees in a whole circle. And 15 seems like a it will go reasonably fast. We'll be able to see it moving, but it's not going to be too fast if it changes by 15 degrees. Okay. How is everybody doing? Brilliant. Dane has a thumbs up. That's good. If you pop something in the chat to let us know you're ready for the next bit, or do a thumbs up. Brilliant. Thank you, everybody. You're great. Oh, you're doing so well. Oh, and chocolate. Dane and I were talking about advent calendars with Carmen earlier today, and now I want chocolate. All right. So what we're going to do next is we're going to send it the instructions. And now we're going to start with a control, because we want to send it this instruction again and again and again. We want to change it, and then we want to change it again, and we want to change it again, and we want to change the angle again. But I don't want to change it like 10 times, because I'm very lazy. And most people who are computer programmers are very lazy. So we like to write short code. We're going to use this block here, this command here that says repeat while. Okay. We're going to put this repeat while underneath this. And this is a kind of instruction that you might be familiar with from Scratch or something, that says, do whatever is in this loop, as long as this condition, the answer to a question that's in this triangle bit is yes. And so we're just going to say, I want them to do it forever. So if you go to math, I don't like saying math. If you go to maths, and then you pick this little triangle here that says 1, and then a symbol, which is less than and then 1, pop it here, click it in, it makes that little pop sound to know, so you know it's in the right place. Then I'm going to change this less than to an equals. So this is going to ask the computer a question, ask the Arduino a question. It's going to say, Arduino, does 1 equal 1? And the Arduino is going to say, yes, of course it does. So because the answer is yes, it will do whatever is in this loop, and it will carry on doing that until 1 does not equal 1. So basically forever. All right. Now, what we want to do is we want to change our angle. Okay. So it's going to start out at this. And every time we go through this loop, we want to add 15 degrees to our angle. If you go back to variables, and then you have this command, which is change angle by a number. I'm going to pop this in here. Instead of change angle by 0, we're going to put it change angle by this amount that we've said we want to change it by. Okay. So it's going to go in here, and then it's going to say angle has gone from 0. We're going to change angle by 15, and it's going to go to 15. All right. And then just 2 more commands for you. We're going to go to output, because we want to send an instruction out to our servo motor. And you'll see a new command that we haven't used, but a really helpful one that Tinkercad has, which is rotate servo on number pin to a certain number of degrees. So we're just going to send an instruction from the Arduino to the servo motor that we want it to be rotated to a certain number of degrees. So we're going to pull this out, pop this here, and the angle that we want it at is our nice variable angle. Like that. Okay. And then one final thing, just because it's going to help us a bit to see what is changing, we're going to use printing to the serial monitor again. And I've said that was the final thing, and it's not, because we're going to have another command to make it work as well. So print to serial monitor down here. And we're going to print the angle. So we're going to just make sure that it's going to the angle that we think it's going to by printing out to the serial monitor, which will be down here. Okay, now that would work, but computers are a lot faster than us. And so it would keep changing so quickly that the poor little servo motor would find it hard to keep up. So we're just going to build in a little delay, like we did when we're doing flashing lights. So we're going to go to control and then wait. And I'm just going to say wait for half a second. Okay. All right, now if you have any questions, do pop them in the chat. And I'll wait for a few moments so that everyone can catch up before we simulate our circuit, before we test it out and see if I've made any mistakes, which is always possible. Do you have questions? Do pop them in the chat. The others are really happy to help. I have forgotten a thing. Well done, everyone that spotted my deliberate mistake. I'll say it's deliberate. It wasn't really. So if you look at this command, I'm sending an instruction from the Arduino that says rotate the servo on pin 0 to be a certain number to a certain angle. But there's nothing connected to pin 0, so nothing's going to happen. My servo motor is connected to pin 2, so I need to change this pin to pin 2 so that it's sending the instruction out of the right pin. Otherwise, nothing would have happened, and it would have been really boring circuit and really boring code. I'm sure you all spotted that that was a deliberate mistake, right? Okay. Now let us see if we are ready to go. So hopefully this will do is it will just turn around 180 degrees. So cross your fingers and we're going to start the simulation. We're going to do that here. So we're going to start simulation and let's see what happens. It's thinking about it and then it's moving, 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 moving. Yay! Oh, fantastic. So it's moved all the way around. Now you'll see that it's stopped. And that's because that's how servo motors work. They like to go around 180. They can go around this way or this way, but they don't go all the way around continuously normally. This one doesn't anyway. There are other motors that you can use to do that, but we're going to use servo motors because they're nice and simple. All right. So did anybody's servo motor move at all? Pop something in the chat if your virtual servo motor moved. Yay, fantastic. At least somebody's did. That's brilliant. Oh, and that looks like a happy face. Dane's was working as well. Oh, brilliant. It works. Fantastic. Congratulations, everybody. Honestly, you're doing so well. So now, just like we've done for the past few weeks, we're going to build our circuit in real life. So I'm just going to stop my screen for a second and spotlight me and Dane, because we've both got servo motors here. So if we show you what they look like, then you can just make sure that you know you've got the right one. So oh, they look fairly, we've got the same kind, don't we, Dane?
Beast, yeah.
Yes.
Mine has a black.
Oh, mine's got a white little thingy on.
Really different colours going in, but otherwise it's like a tiny little, it just looks like it does on Tinkercad. So
yes. So yours does, my blade's actually slightly different. So I've only got 2 blades on this. You see it comes off and then you can put it onto the motor like that. Just going to.
You're right, Sophie. That's how they come. So they might come out of the box. Ooh, where's it gone? They might come out of the box like that with nothing on top, and you then will have another little packet of items in there, and that's where you can either place the blade on yourself, can't you? But there's also a little screw that you can screw in to attach it even more securely. But for now, I think the screw isn't totally needed. So if you just place it on, there's a bit of grip there. But if you want to do the full thing, there is a little screw that I've screwed it in.
You've done that.
Attach it.
Brilliant. So that is, if you look at Arduino Cam, that's it in close up, and you can see that there are 3 little holes here with the 3 wires that are connected to, just like on Tinkercad. But sometimes, just to be annoying, they put the the ground and the power and the signal in different orders. It's just to annoy you or to annoy me. But they normally tell you. So on the side of my my servo motor, can you read that?
Oh yeah, it's a diagram. Yeah.
Yeah, there's a little diagram on the side of my servo motor that tells us which one is the ground, which one is the signal, and which one is 5 volts. Do you have something similar, Dane?
No, there's nothing like that. But I think the colours match up to the Tinkercad colours more accurately.
That's the other way that you can look at it. All right. So let's start to build our circuit. I will reshare my screen so that you can see that, and then I'll spotlight Dane as well, so you can see Dane building it along. Okay, is that all right, Dane?
Yeah, great.
Fab.
So the only thing that I've sort of cheated with a little bit, because it's a faff, is I've put this little extended LED wire into the breadboard, but I've just put that in there because it was a fiddle to do. So just ignore that for the time being. So just think of this as a completely plain breadboard, and that's my servo motor there. So all I'm going to do is I'm going to follow Sophie's diagram, which is the same as mine. So I'm going to put my little servo motor down. So I'm probably going to start with my 5 volt power. So I'm going to add my power to my power bar. So my 5 volt from the Arduino is going into my power, so the plus bar on my breadboard like that. And then I'm going to ground it, and that will make sure that everything is working as it should. So maybe I should have a slightly longer ground, but I'm just going to make do with that one. So that's now going from my ground pin into the minus bar, so the ground bar on my servo motor. So that's nice and straightforward. And then what I'm going to do is I'm going to use a white cable for my instructions. So I'm going to leave that there, but I'm going to finish off plugging in the power and the ground. So getting my Arduino right. So I'm a bit colorblind, but what I can see is the 3 different colors. One's blackish, which might be brown. And then there's a reddish one, and then there's an orange one. So Sophie, could you just help me with the colors there?
Yes, so normally black is for ground, or brown is the ground one. Red is power, so the 5 volts. And then the other color is normally the signal.
Right, so this one on the, so this one here, I'm thinking is my ground. So I'm going to put my orange ground pin into there. And I'm going to attach it to my ground bar on my breadboard, just like that. Oh, sorry?
Sorry, your camera decided it was going to look at your keyboard instead of the Arduino for a moment, but it's back on the Arduino now.
So well, that's good. So we've got into the ground on the board, on the Arduino board, and then the ground in the servo motor controller. The middle one is my power, so I'm going to plug my power lead in there, and I'm going to attach it to the power bar, so the plus bar on my breadboard, just like that, nice and straightforward. So this is now everything powered up, but we don't have any control. So my last one is my control lead, and I'm going to put that in using a white cable. So, and I have also connected mine up to pin number 2. So I'm going to pop that in my digital pin 0, 1, 2, just like that. So hopefully that's all working. So I'm all plugged in and ready to go.
Fantastic. Thank you very much for doing that for us, Dane.
There we go. So let's see if it works later.
Let's see if it works. Yeah. All right. So just as before, we need to, so now we've built our virtual circuit, we've coded our virtual circuit, we've built our real circuit. So now we need to send the code to the real Arduino. So just like before, we're going to do that by looking at the code. I'll just move that over here for a sec. And then changing, instead of just looking at the blocks, changing to blocks plus text. So we get our code in this other language that we call C++. You highlight all of this, copy it, Control C, and then move it over to the Arduino app. So I've already put mine in, so I'm just going to copy it in, put that into there. Could one of the helpers put the link to the Arduino app in the chat for us, please? All right. Now there is an extra step that we need to do for this that we haven't done before. You'll see in the C++ code there is this thing that says include servo.h. And now that is a set of instructions that someone else has written so that the Arduino knows how to talk to a servo motor. So it's like translating it into language that the servo motor needs. So it's a set of instructions that somebody else has done. There are lots of these kind of things because loads of people use Arduinos. But you do need to tell Arduino that it needs to be able to read these instructions. It's called a library because it's a set of instructions, and libraries are great for instructions. So if you click up here, you'll see the one that says libraries. And then there are lots of different ones. You can see all of these different types of, there are 5,270 different libraries, different sets of instructions that people have already written for you. But we want the one that's for the servo motor. So if you just write servo in here, you'll see one that comes up that is called servo. And your one, instead of saying remove, yours will say add. Mine says remove because I've already added it. So you just need to go to that and then click add. And then that will mean that it can talk to all of this library that this lovely person named Michael has already written for us. Okay, so click on that. And if it says remove, then you've done it properly. All right, then we go back to the code. Just like we have done before, we then check that our Arduino is all connected. So you go down here, mine says selected because I've already connected my Arduino up, but yours might say select device if this is the first time you've opened the Arduino app today. So you click on selected, and you realize that you've, or I realize that I've disconnected my Arduino, so it's not happy about that. So I'm just going to reconnect it. That was the ding, ding, ding of it reconnecting. And you see here it is. My Arduino is open and I'm going to connect like that. All right. And now you should see it says selected Arduino. All right. Then you head up to this compile and upload. You click that, and then hopefully that will send it to your Arduino. And I've got 100% error because I just disconnected it and reconnected it, and it's having a grumpy day. But hopefully you won't have 100% error. And I'm going to try to close that, to close the tab, and then put it in again. Arduino app. Okay. And then code, and we've got it. Check that this is connected like that. And then I'm going to press compile and upload, and it's uploading, and it's done. And now my little Arduino, my little servo motor is moving, which is awesome. Oh, it's having a lovely time. All right, did anybody else's move? Yay! I can see that Jan's is moving. If you do have any problems, then pop it in the chat. And I'm just going to show the code again for you so you can see all of this. Oh, hooray, some people's are moving. So If it says it's done, but it's not moving, then there's a good chance that there's something not quite right with your circuit. So unplug it from the computer and double check your circuit, because we should always unplug our circuits from our power sources, from our computers, before we change any components, just to be on the safe side. Oh, fantastic. Well done for the people that it's moving. If it's not moving, don't worry. Now, I think
I've got mine working, and I could show it if that's useful. Although I do have, and I think this might be something that we cover in a second. So I'm just going to stop.
Sophie, while Dane's doing his sharing, could you in a moment show the tricks for helping fix the 100% error again? We've got a couple of people doing it. It's much easier to show than to try and type in the chat.
Yes.
Thank you. So those of you who've commented about the 100% error, just wait a couple of minutes and we'll do it again.
All right. Dane, did you want to show yours first, and then we'll...
Oh, yes. Could you stop sharing your screen?
I can. Or at least I can if I find the Zoom control bar.
Excellent. So what I've done here is I've attached the little LED onto the windmill of the servo motor, and if I plug it in, it should. Yeah. It resets and it moves. But of course, what we do find with our Arduino powered servo motors, they tend to only like a 180-degree turn, don't they?
They do.
Maybe we need to find a way to make it go backwards.
Well, we might just do that right now. Well, we might show people a few tricks to get rid of the 100% error, and then have a go at moving it, making it go backwards. Right. But I love that you've added your LED to it. I tried to add an LED earlier, but then it pulled out my wire because I hadn't attached it very securely.
Oh,
I know.
It's really pleasing having it moving.
Yeah, it's very cool. All right, I'm just going to share my screen and go over a few tricks for getting rid of the 100% error. So one of them, as you saw when I did it, the Arduino sometimes gets a bit grumpy with you if you unplug your Arduino. If you try and then you want to change something and you unplug your Arduino and then you plug it back in, sometimes it gets a bit grumpy with you for that. So the easiest way of fixing that is just to close the Arduino app tab on your browser, open it up again, and then just do it again. It's a bit silly, it just resets it. And it's like, oh, you meant that's Arduino, fine, okay, I'll talk to that one. So that is one of the ways to fix it. Another quite common problem that we found is that over here on the left, you can see that I just have one file here, which is called jyoti.ino, because I started this tab on Jamboree on the Internet Day, and so I called it Jyoti. If you've got two files here, then delete the one that you're not using. Delete the one that's not, it's sometimes .c. Is it .c? Yeah.
Sometimes it's .c, yeah.
Sometimes it's .c, but delete the one that you're not using, which is often the .c one, which you can do by right-clicking on it. It won't let you do it if you've only got one file, but if I had two files, then I could do it and a delete would come up here. So you could just delete that and then try it again. What are the other? So one thing to check, another way of checking is if it's your code or if it's something to do with sending it to the computer, sending it to the Arduino. We use this play button, which is compile and upload, but you can just check it and compile it. So that won't send anything to the Arduino, but it will check that your code is okay. So if you just do check and compile, if that's fine, then you know it's something to do with the fact that it's finding it difficult to talk to the Arduino for some reason. And then also double check that you've got your Arduino selected. It shouldn't be the one that says PCI serial port. Sometimes that comes up. Check that it's connected. Have I missed one of the tricks, Sarah?
Maybe if check with the code checking about the brackets and the slashes and what it looks like, if that's the problem. That's one that happens quite often.
It is, yes. It's really easy to copy everything apart from the very last bracket or something, and then it gets very sad because it's like, no, I need all of my brackets. Every single letter, every single thing is important. Oh, and I've just seen that someone's working. Fantastic, well done. Brilliant. So well done to everyone who's working. If it's not quite working yet, like we said, don't worry, we're being recorded. You can watch the recording back and pause and until you get it right. And we've got the troubleshooting. We'll also send you the instructions. All right, I reckon that this group are amazing enough that we can get it to move backwards as well and still have time for Dane to tell us a little bit about the exciting stuff that's happening this weekend.
Definitely.
So if you head back to the code, I'm just going to change it back to blocks so that it's a bit easier for us to see all of the things. What we want to do is we want it to go forwards, and then we want it to go backwards, and then we want it to go forwards again, and then we want it to go backwards. And we want it to change whether it goes forwards or backwards once it's got to 180 degrees. So once it's moved around half a circle. Now we can do that using some clever if statements. So we need to ask the computer a question. Firstly, we want to ask, is this angle more than 180 degrees? So we're going to use an if statement here. We're going to pop it at the bottom, and we're going to ask it a question. Is angle more than or equal to 180 degrees? So we need some maths. And this one is less than, so we can move this one in here, like this. We want to ask it about angle. So we go to our variables and click angle. And then we're going to say more than or equal to, which is this one that has, oops, sorry, I'm just going to zoom in so you can be sure that you're getting the right one. The arrow with the line under it, with the bigger thing on the angle, more than 180 degrees. Okay. All right. And if it is more than 180 degrees, what we want to do is that the next time it goes round, instead of adding 15, adding this value called change, we want to take it away or add negative 15 degrees. So what we're going to do is we're going to change this. So set change to whatever changes times -1. So instead of adding 15, it will take away 15. We'll do some maths. We're going to do some multiplication. So we want to set change to change, then times -1. Now, we are going through this quite quickly because I want to make sure Dane has a chance to show us the cool things that are on his floor at the moment. So don't worry if you haven't quite got it all, because you can always pause us and we will be sending it out to you later as well. So just to recap, every time it adds 15 degrees, this change adds change, we're going to check if the angle is more than 180. So if it's gone all the way around. And if it is, we're going to say, actually, I want change to be -15, not +15. Okay, so then it should go to the next one and it'll say change angle by minus 15 degrees. And so it should start to go backwards. All right, if we've done it right. So let's try starting the simulation and seeing if it works. You ready? All right, any problems, do pop them in the chat. Okay, so we're starting. It's moving around. Excellent. This is all working fine. Now it gets to this point and it's moved backwards. All right, and then it gets to 0 again. We can move forwards and we've moved backwards, which is brilliant. But now my angle is on, it wants to move this way, but the servo motor doesn't want to move over in this direction. So what we can do is exactly the same thing as here, but instead of if the angle is more than 180, we can say if it's less than 0 up here. Okay, so we're just going to copy this bit of code, and I can't remember if I've shown you copying code before. If you right click on a piece of code, you can just put duplicate like that, and then that saves you from getting a whole bunch of other stuff. So I'll just pop it in there. So I've just duplicated that whole thing. It's much quicker. It can be much quicker than redoing it. So what we want to do the same thing. We want to change it, but we want to do it if it's less than or equal to 0, like that. So if it's gone all the way back up to here. All right. So hopefully what will happen is it will go this way and it'll say, oh, it's more than 180. I need to change. I need to start minusing 15 instead of adding 15. Then it will go all the way back and then it will go, oh, wait, I'm less than 0. I need to start adding 15 instead of taking away, if we've done it right. So let's start the simulation and cross your fingers. All right, working okay so far. Moving this way. Now it's moving backwards. All right, and when it gets up to the top, it should go back the other way. Hooray! And now it will just carry on doing that forever and ever and ever and ever, which is really good and what we wanted. All right, so we did do that quite quickly. So do remember we've got the troubleshooting and you can pop something in the chat. Pop something in the chat and we'll try and help you that way as well. All right, well done, everybody. I know that some of you have got your circuits moving, your real Arduinos moving, and lots of you have your virtual ones moving. Let us know if you've got your virtual ones moving backwards and forwards. And if you want to do that in your real circuits, you just do exactly the same as before. So changing blocks to blocks plus text, and then copying the new code into Arduino and uploading it. Well done, everyone. I'm going to stop my share so that Dane can tell us the exciting things that he's been getting up to recently.
Excellent. Thanks so much, Sophie. And so I've just put it into the Arduino and look what's happening. It just goes backwards and forwards, spinning through 180 degrees with a little LED on top. So by now you've coded and built an LED device. You've made it so that it's light sensitive. You've made it so it can be controlled by a button, and you've added a little bit of movement to it. So you can combine all of those 4 key things to make light sensitive moving LED sculptures, which I think in 6 weeks, just having an hour in the evening on a Wednesday night, I think is a really great achievement. So I'm so happy that everyone has stayed through and been part of this. Last year, we had a request from people to make a certificate, and we will be sending by email a Glow Your Own certificate round with all the different, well, I've just mentioned all the different bits and pieces that we've learned throughout the 6 weeks. So you'll get one of those in your inbox. So hopefully you're getting all of the emails that we send before and after the sessions. So that will come into your inbox as usual. So the thing that I've been up to now, this is about this weekend. So the Oxford Christmas Light Festival is happening this weekend on Friday and Saturday, and there are events, we mentioned it a little bit last week, but there are events all over the city, in the centre of town, but also around in different places. So we're going to be in Blackbird Leys at the weekend, and we're going to give you a sneak preview. So I'm going to take my little thing here, and so we've been experimenting with LEDs like we've been doing with our smaller scale Arduinos, but we've had a bit more time on our hands and you can see it working now. So this is a voice activated, so I'm just going to turn my camera around. So this is a voice activated LED sensor that's been wrapped in some pipe. So if I make a noise, it will flash. And so we're going to be building this onto the side of the Blackbird Leys Community Centre, and we'll be switching it on at 6 o'clock on Friday night. So we're going to be building it all of tomorrow. So if you happen to be in the area, do stop by and say hello. But then we have got the switch on Friday at 6 o'clock, and it's going to be on for a couple of days. So this thing's flashing to its heart's content. But not only do we have LEDs, we've also bought these quite fun torches. So they're not like a regular torch, but they look like a regular torch, you can see. So if I shine some light onto my ball that's flashing furiously, so I can write almost a word. I haven't practiced this, so you can see it's not very well presented, but I can write with my UV torch. I can write down our project that we've been doing. It's known as GYO. So, and you can come and play with these over the weekend. So you can listen to or see the sound responding, and you can play with some UV and photosensitive paper that will glow in the dark as part of our Oxford Christmas Light Festival offering. So that's starting on Friday at 6 o'clock, and we'll be also doing it on Saturday too. My thing is still going round and round. Look, it's just constant. So hopefully we'll get to see a few people at the Glow Your Own switch on, and you can see the fruits of our labour. So let's get everybody back up. So I'm going to unspotlight myself. I can work out how to do that. Maybe Sophie, can you help me? Thank you. So that's all we've got to really share. So we will be having troubleshooting for the next 30 minutes, so please do stay behind. And if you don't have any problems, but you have got your Arduinos working and flashing and moving, please do stay behind and show them to us, because it'd be so good to see what you've been doing. I'm very much a computer novice, so I'm really happy when I can get things making movement and light, and I do hope that you've got some really good things to show too. So well done. It's been tricky, so we've been kind to ourselves throughout the process, and everyone's caught up, I think. Right, so I'm going to stop. Oh, sorry. Yep.
I was just going to say, we had Luke had a very good question in the chat about how to unplug an Arduino from the computer and still have the circuit on, so you can hang it up somewhere. So I just wanted to show that in your boxes, if you've got one of the Arduino kits, there are some cable, like a little cable that looks like this, and a 9-volt battery. So you can connect the battery to this, and then the other end, there's another spot on your Arduino next to the USB cable that you can put that in. So you don't want to plug that in while it's connected to the computer. Make sure you've unplugged it first, but then you can power it with this. or you can use your cable that you're connecting it to the computer to plug it into a battery pack. So if you've got a battery pack for a phone, one of those sort of little round ones, or a sort of big bulky one, anything with a USB port, you should be able to plug it into that. So those are a couple of ways that you can take your Arduino away from your computer and have it displayed in a window or something. So hopefully that's helpful. Have a dig. If you don't have one of our boxes, you might not have one of these, but if you got one of the boxes for us, hopefully you've got one. My box was from last year, so maybe it's a different box. But have a dig around, see if you can find something that looks like this. They're very handy.
But then, yes, you're right. There's always the LED, the kind of mobile phone battery power bank, which I often use, which is really good. And then you can just recharge it. So there's a couple of different options for keeping this thing mobile. But thanks, Sarah, that's really good, using different kind of power supplies and exploring those things. Yeah, loads of ideas. Okay, so shall we sign off and do the troubleshooting? We'll thanks, Sophie, for all the great instructions. Carmen, thanks for the creative session last week. It was great fun. Sarah, what would we be doing without you? And Jan, Caitlin, James, and also Jamie, who's not able to make it here tonight, have been super helpful and sharing what they do as their engineering day jobs. And we also had Kathy last week doing some craft work. So there's a nice team here, and now we've got sort of 80 more people doing coding, which is wonderful. So we've had about 80 or so Tinkercad codes. So thanks to all of you, 80 and more, if you've been watching online, for joining in Glow Your Own this year.